This is our final channel video, and it looks like the last thing that we did, let me get this out of the way here. The last thing that we did was to create the backup files of our project. But once that's finished, then I need to reload the project back into QGIS. I'm going to do that right now. And I have QGIS right here. Just open that up, and I don't need that anymore. Sorry, my error message. It's going to restore everything to its original state, and then all we have to do is just double click on our project. It's going to pretty much stay in the same spot. And click OK because some of our data needs to have a transform thing. Let's see, click yes to load the model. It's going to be a little bit slower because the model's getting bigger, but it's usually pretty fast. Now, if you see this really, really slow, sometimes that means that your data is like in the wrong place. So if your QGIS does all its processing on the C drive. So if you have your model on the D drive, or if you have your model on the H drive or the user drive, it could really slow things down. So just be aware of that. You know, if you want to wait for it, that's perfectly fine. But if you don't, then maybe put it on the C drive until you're finished with it, which is exactly what I've done for you for the training. So back here in your coastal data, all your data is on your C drive. Okay, let's go ahead and get back in here because now we are going to take the run that we finished and let's just take a quick look at the channel. Let's see, so we go to our project export folder, and this time we have the WEIR export test was the final run that we created. And so what we have in here is the summary.out file. So if you look in the summary.out file, it's going to tell you what build you're using, and it's going to give you your simulation time on this side on the left, and the time step, the average time step in the middle, and then volume conservation information. So what we don't want to see is we don't want to see these numbers getting high. Now, if we apply a tide control, then these numbers you will see some volume conservation issues kind of regardless of what you do, but this looks really good. So I'm just going to stick with it. I'm just going to stick with this. I think I might have turned my tide condition off for this run, but we'll see. We'll see in a second. And so you see that I ran this for 12 hours. So I didn't run it for the, wait, I'm sorry, that's not, yeah, that ran it for 12 hours. I didn't run it for the full 24 hours because I just need to get that water down to the end of the channel so I can see if the channel is running correctly. So I turned that tide stage off in this particular run, and I only ran it up, you know, get that peak kind of through the system. And so you get the total amount of rainfall that's up to that 12 hours, those 8 inches. So it's a lot. Your inflow hydrograph was substantial. You can see that your inflows right here give us an additional 2,000 acre feet. And we have water lost to infiltration, 3 inches. And channel flow, our channel storage is 221 acre feet. And our let's see, channel outflow. Well, it's not going to give us outflow because we set it up as a termination, but it is allowing outflow. And so our floodplain outflow will be the total outflow from the grid is 435 acre feet, which would be the amount of water that's flowing in the channel and the rainfall that's collecting and outflowing right here as well. Okay, and so we also see that we have 20-foot cells and there are 240,000 of them, and this gives us the area of our system. The computer runtime took a half hour to run that up to that length of time, and it gives you like the termination date and that simulation summary. Okay, so that's summary.out. And we also have a couple of channel files that we can quickly review. So we have the veltime c.out will give us a velocity in our channel. So our velocity, our maximum velocity in our channel was about 4 feet per second. So that's probably okay for this channel. If you are concerned about a velocity in a channel, you can do an open channel flow calculator and compare the velocity from here to the velocity in your channel. I like to use the one from San Diego State, the San Diego State open channel flow calculator. Whoops, I might need to get the second one. Always have it in here. And you can just look up SDSU online calculators and you can grab the one for pristine channel, set it to customary units, put in a discharge, put in your channel information, your bottom width, side slope, bottom slope, Mannings, and then you click calculate and it will give you a normal flow depth velocity or a normal flow velocity. So you can compare that to what you have in Flow 2D and see if that's close. And it usually, I don't know, I do not see any surging in this channel because it looks really clean. So I'm gonna assume that that's good. So velocities look good. Let's go ahead and look at the Chan max dot out. Chan max dot out is giving us these are our maximum discharge in column number 2. And this is the start of the channel, and then the bottom of the channel is down below. And if our maximum discharge and the time and our maximum stage and the maximum stage time don't really match, that's an indication that you might have some instability in this channel. So you'll just want to check all these out and see that they're kind of doing what they're supposed to be doing. And they look pretty good to me. I don't see any problems with that. And then of course, we terminated that channel down there. So this one doesn't get a discharge because it's a central difference. And so it doesn't have a downstream channel element to share with. So that's why it gets a 0 discharge. I'm gonna close that up. And that is looking good. That I don't have any problems with that one. So the next thing I want to check is maybe the hydrographs as they're flowing through the system. Now, in order to do that, you'll take your Flow 2D Pro. So I'm just going to take you there the normal way. C drive, program files x86, Flow 2D Pro, and then you find the Hydrog program and you copy it, and then you back out of there and go back to your training, project export, weir test, paste that inside of there, and then if you're sorted by type like I am, it'll go to the top. And so then you can just double click it and it's ready to go. So if you plot the channel hydrographs, you can just grab that first node, click OK, and just start moving downstream and review every single channel. And if you start seeing spikes or weird things happening, then you'll know that you need to fix something. But it looks pretty much okay. Just gonna keep going down through here, and I want to do every single one. So it's starting to get a little fuzzy, but it's not instable. That's not unstable. That's just a little bit of noise in the math, not an instability. Still looking good. There's quite a few of them, so just keep working downstream. Little bit of getting a little fuzzy in here, but still, I still think that's still very valid flow. There's nothing spiky going up and down, crazy spikes. It's looking real good. And we're probably going to go all the way to 0 or to, like to hundreds on this because even though these are starting to look a little spiky, there's still nothing wrong with this data. It's still good data. I'm trying to go as fast as I can. Okay, I'm gonna return to the list, and I'm gonna take us down here to around here. Yeah, still looking real good. And just keep going downstream. You typically will get your instability on the rising limb of the hydrograph. And we should be coming in on the bottom of this. It keeps clicking, it keeps beeping at me because it's like, stop clicking it so fast. Yeah, looking good. Nothing wrong with that channel. That channel looks pretty valid. Okay, so I'm just gonna, I'm just gonna exit out of here because you get the idea. You just want to check every single one and you're looking for instability and it looks great. Okay, so close Hydrog. Don't have any problems with Hydrog. You can then go to the ch volume.out. So I'm going to hit the C key a couple times and that will take me to chvolume.out. And what you have here is, what I'm looking for here is the volume conservation. And you see here, I don't have any volume conservation issues. That stays really low, so that's great. There's some other data in here too that I never use. So I didn't set up infiltration in the channel. I didn't set up evaporation. We didn't have any overbank flow. Well, we might have had some down below, but yeah, you got your overbank and a little bit of return flow down below. And then channel outflow, we didn't have any channel outflow because of that, because it's set up as a termination. Rain inflow plus rain and channel storage. Okay, so that's that. So don't need anything else out of there. And the last thing that you can do to check your channel is to plot it with profiles. So you can just double click the profiles tool and wait for it to load. It does take a bit of time to load. Especially if you haven't run the model, it seems like it takes longer to run. I'm going to click View Profiles. That's the first button, Maximum Water Surface Elevation. And you can see here this is where I put those little drop structures next to those weirs. And you can see here that it looks pretty good. And even though this is my water surface elevation, and you can see that my banks are a little jagged. Sometimes they go up a little bit high down in that down in the mangrove area, which, if you've been in a mangrove, you know that the banks are pretty crazy in there. So I think that's probably okay. This bank, these last two are on that bridge, are up on that bridge. So one side of the bridge, this is the downstream side of the bridge. This is the upstream side of the bridge. So those are a little bit higher. And then this one is that area that's like just upstream of the bridge, which was pretty low. So that one looks like we're kind of barely above sea level on that one, but it's still okay. There's nothing wrong with this. There's nothing wrong with these banks looking like this. And again, I forced this channel to be relatively uniform due to that mobilization of those sandbars. I think that stuff's just gonna mobilize and just get swirled around in there. I'm not too worried about that. So that looks good. Now let's go ahead and just shut this down. Well, we can do a couple other things. You can, let's see, if you click View Segment Bed Slope, you can view local reach. So I clicked this button, don't click this button. And then I clicked this button, and then I can just click anywhere in there, and I can look at the cross section. And so you can see here that you have, here's your cross section. And you can go upstream and downstream and review various different cross sections. Okay, that's how profiles works. I'm going to close it out. And again, I don't need to save anything, so I'll just exit. And again, all of these programs can be run from within the project folder, and that's a great thing to do because then you keep the engines and the processor programs with the data. All right, let's take a quick look at, let's go ahead and load the channel into QGIS. That'll be our next little step here. So I will click the cross-section editor, and I will import the peaks of the channel from the highchan.out file. So I go back to my project export folder, and I open highchan.out, and it's going to read the data and load it into QGIS. And then I can use this guy right here, this little profile tool, click my channel, and then click that again, and it will load the channel data into the table. And so then you can kind of zoom into this data, and you can pan around in here, and you can kind of see information about this channel. Unfortunately, it's not quite as cool as like some of those other profile tools that kind of tell you where you're at on the map, but it does look pretty cool. And then if you want to reset that that plot, you just hit that little A in the corner. So as soon as you scroll or do something like that, you just lose your data, you can just reset it. And you can see that it looks pretty good. And then we know where we are because we know like we got a weir right here, and we have another weir right here. Of course, it's backwards, but that's okay. We can figure that out. And that is kind of how you would start to review your channel. And then if you ran into a problem, I have videos to show you how to fix and to get channels to work correctly. So if you get to your channel on your own project and you find that you're struggling with it, and it's not running correctly, check out some of those channel videos, or get some tech support. Okay, so that's it for channel modeling. I'm going to go ahead and stop the video, and then we'll move on to the culverts.